Locking technique used for the concurrency control. First is the binary lock. It is the simplest form of locking. A data item can be in one or two states, locked or unlocked. Prevent a multiple transaction for accessing the same data in simultaneously. In example, in a word processor, two users cannot edit the same document at the same time using the binary lock. Second is shared exclusive lock. Allow a multiple transaction to read a data items concurrently. It's a shared lock. Only one transaction can modify a data at the time of exclusive lock. In example, in the library catalog, multiple users can view books details simultaneously is a shared lock, but only one user can check out a book at the time exclusive lock. Third is two-phase locking, is also called a 2PL. Ensure the serializability of the transaction. Divide the transaction exclusive into two phases. First is growing phase, second is the shrinking phase. Growing phase means transaction acquire lock. Shrinking phase means transaction release lock. Once a transaction release a lock, it cannot be acquired any new locks. In example, in an online banking system, a transaction transfer a fund between the account would first acquire an exclusive lock in the both account growing phase, and the release after the transfer is complete shrinking phase. Stick to phase locking S2PL, variant of the 2PL that prevent the deadlock, require the all exclusive locks to be held until the transaction committed. In example, in an airline reservation system, a transactions booking a flight would be hold exclusive lock on the flight seat and passenger information until the booking is confirmed. Fifth is optimistic locking. Assume that the conflicts are rare and only check for the conflict before the committing a transactions. Can improve the performance in low conflict scenario. In example, in a version control system, optimistic locking allow a multiple user to work on the same file concurrently with the conflict detect only when the changes are committed. Sixth is deadlock handling. Locking technique can lead to deadlocks where the two and more transactions are waiting for the each other's lock. Deadlock detection and resolutions mechanism to necessary. In an example, in a train reservation system, two transactions trying to booking the same two seat might enter the deadlock, requiring one transaction to be absorbed in resolving the conflict.